we are going to see the parts that make up the defrost timer. The numbers on the outside of the disk represent 24 hours. The light numbers represent the hours of the day, while the dark ones represent the night hours. Let's take a close look at the defrost timer and set the clock to 10 in the morning. The numbers on the inner disk represent the duration of the defrost. We are going to put the defrost cycle on for 30 minutes. Looking closely at the defrost timer, we can see 4 pins, which, according to their position, represent the time the defrost starts. In this case, the pins are separated every 6 hours from each other, so the walk-in freezer will have 4 defrosts in a period 24 hours. At the bottom of the defrost timer, there are 6 contactors, each 1, 2, 3, 4, and an X. Note that there is a jumper between contact 1 and 2. How the low pressure control works. Let's take a close look at the low pressure control, in which we can see 2 columns. The columns on the left represent the differential pressure, and the columns on the right represent the pressure cut in. In form of the equations, we will have pressure cut in minus differential pressure equals pressure cut out. In this particular case, we can have pressure cut in 36 psi minus differential pressure 20 psi equals pressure cut out 16 psi. That is, when the pressure drops to 16 psi, the contactor will open. How the refrigeration cycle works. The defrost timer has to be in refrigeration mode. Means close contact, allowing current flow to terminal 4. The defrost timer must be in cooling, so the normally closed contacts remain closed, allowing current to flow from terminal 4 to terminal block 4. When the thermostat is calling for cold, it closes its contacts, allowing current flow to energize the solenoid valve, allowing refrigeration flow, and the low pressure control sends the high pressure, as we can see at the pressure gauges. The low pressure control closes its contacts, energizing the 120 AC volts coil. The coil creates a magnetic field that closes the contact terminals, energizing the compressor and the condenser fan motor. The evaporator coil starts cooling, but the evaporator motor is not working, as you can see, because one of those motor terminals is connected to FD, which means fan delay. The FD closes its contacts when the temperature drops to 35 degrees Fahrenheit, energizing the evaporator motor. When the thermostat reaches its set point, in this case 40 degrees Fahrenheit, it opens, de-energizing the valve, and therefore closes the passage of the refrigerant, and the compressor starts pumping down, keeping the refrigerant in the receiver. In the gauges, we can see the pressure start dropping, and when it reaches 0 psi, the low pressure control opens its contacts, de-energizing the 120 VAC coil, therefore open the contacts, turn it off the compressor and the condenser fan motor. However, the evaporator motor is still working until it reaches the 65 degrees Fahrenheit. Once the temperature reaches about 65 degrees, the fan delays open its contacts, turning off the evaporated motor. How the defrost cycle works. In the middle disk, we put the time that the defrost time lasts. In this case, we select 30 minutes, which is the time that defrost lasts. We turn the knob counterclockwise until we reach the next pin, which is at 2 p.m. When this happens, the contact of terminal 3 closes and the contact of the terminal 4 opens. The current no longer flows from the terminal 4, de-energizing the evaporated motor and the solenoid valve de-energizing. And this causes the refrigerant not to flow, lowering its pressure below 16 psi, opening its contacts and de-energizing the 120 VAC coil. At the same time, open the contactor, de-energizing the compressor and the condenser fan motor. When the contact of the terminal 3 closes, allowing current to flow to the terminals H1 and H2. To exit the current to the heater element, turn it on. The defrost timer has 2 ways to exit the defrost cycle. In this case, the duration is 30 minutes, or by the defrost timer, FD, it reaches 65 degrees Fahrenheit. When the temperature rises more than 65 degrees Fahrenheit, the defrost timer closes its contact, energizing the solenoid at the terminal X at the defrost timer, causing the defrost timer to exit the defrost cycle and start the refrigeration cycle again.